Okay, in this lecture I will discuss Fuzzy VIKOR and MCDM approach. Fuzzy VIKOR is a very famous multi-criteria decision-making approach which is totally rely on fuzzy set theory. So in my previous lecture I have already discussed in great detail what is fuzzy set theory, what is membership function, what is the difference between binary set theory and fuzzy set theory. So before going to this lecture, in order to understand this lecture, you need to go through that video. You need to watch that fuzzy set theory, because if you not understand the basic concept of fuzzy set theory, you will not be able to understand this. So the today lecture topic is Fuzzy VIKOR. So what is VIKOR and who first have developed it? So I will just discuss a little bit about fuzzy set theory before starting the VIKOR approach. So fuzzy set theory is, you know that it was first developed by Zadeh in 1965. Deal with the problem in which a source of vagueness is involved. So we have already discussed that mean when the situation is blurred, when the situation is uncertain, you not know, and I have already discussed that mean in the binary we just say yes or no. But when we have a situation, let's suppose what will be the definition of young? So someone say that the definition of young, that those people whose age are 20, so they will be considered as a young. Another one say that those who are between 20 and 30, they will be considered as a young. And the other will say that the age of those who are between 20 and 35 will be considered as a young. So I mean, now you're not responding as a binary. Now you're giving three different options. So now the situation is a little bit fuzzy. The situation is a little bit vague. So a fuzzy number is an extension of regular number. It does not refer to one single value, but rather to a connected set of possible values. So we have already discussed different mean or rating. We have already discussed different scales, for example, Likert scales. So mean 1%, let's suppose equally important. So this is a triangular fuzzy number. Equally important, 1, 1, 2. And if you construct this, so the membership function, as we have already discussed in great detail, the membership function, this is the membership function, mu a, and this is 0, and this will be 1. So if you construct this, and this, so this is now triangular fuzzy number. Let's suppose in the example of, in this case, it will be 1, 1 and 2. In this case, it will be 2. Let's suppose this is 2, 3 and 4. So this will be as a weakly important. Essentially important, yes. 5%, 4, 5, 6. Very strongly important. So mean basically we use the normal 9 Likert scale. So 1% mean 1, 1, 2. These value will be lying in the 1%. In 3%, 2, 3, 4 will be lying, which will be considered as a weakly important. Essentially important will be 4, 5, 6, which showing 5%. Very strongly important, 6, 7, 8, and absolutely important, which is the heaviest one, the highest one, 8, 9, 9. So at this way you will construct the fuzzy set. Linguistic variable, so we have already discussed about linguistic variable, mean a variable whose values are word or sentences in natural or artificial language. For example, age is a linguistic variable if its values are linguistic rather than numerical. Young, for example, not young, very young, quite young, old, not very old, and not very young. So all these are linguistic variable, and this means that these variable values are words or sentences in a natural or artificial language. These are not mean quantitative things. Rather than the quantitative will be 20, 21, 22, 23. If we assign these weight to the age, then this will be quantitative. Okay. So in particular, treating linguistic variable lead to fuzzy logic. So now if we solve this dilemma, that which age will be considered as a young. So now the definition of young will be maybe those who are 20-year-old, maybe those who are between 20 and 25, or those who are between 20 and 30, let's suppose. So now we can use easily while using the fuzzy logic. So this is just a structure, age, linguistic variable, fuzzy restriction, very young, young, old. So very young is being 20, 1, 0.8 and 0.6. So it lies between the binary 0, 1. 20, 25 and 30. Similarly, it's going up. So this is base variable which we representing with the x-axis, which is age. So we can map this with the universal set. So because I already discussed about fuzzy set theory, so I don't want to spend more time on the fuzzy set theory. For this purpose, you need to go through that video and the title of that video, fuzzy set theory. The Vikor method. So Vikor method is very important method which most of the researchers use in different area. I will discuss some research paper, the latest research paper, which means scientists and researchers use in different multidisciplinary area. So Vikor is basically a Serbian name, and the meaning of this is multi-criteria optimization and compromise solution, which was developed by Opricovic in 1998. So still this is not such a old technique, it's only 22-year-old technique. Based on ranking and selecting from a set of alternatives under conflicting criteria. So we have already discussed about criteria, characteristic, alternatives. We have different criteria, different alternative. The question is which criteria, which alternative will be the best one. So the compromise ranking could be performed by comparing the measure of closeness to the ideal solution. So if you remember in the Topsis approach, we use the Euclidean space Manhattan distance formula in which we want to calculate the most ideal solution. So if you understand that approach, this is much similar to that one, performed by comparing the measure of closeness to the ideal alternative. So we will be looking for the ideal solution. The compromise solution could be the basis for negotiation involving the preference of decision making by criteria weights. So why fuzzy Vikor? There are different fuzzy approaches. For example, fuzzy Topsis, fuzzy analytical hierarchy process, fuzzy D-metal, fuzzy Vikor, fuzzy electri, fuzzy SWOT analysis, etc., etc. So basically, we trying to utilize these techniques in order to remove the fuzziness, to remove the blur from a specific situation due to vagueness in the data and ambiguity in decision-making process. Fuzzy set theory has been incorporated into MCDM technique. This method defines an index called closeness to the positive ideal solution and the farthest from the negative ideal solution. So it is much more similar to the Topsis, in which we discuss these things in great detail. The fuzzy Vikor method has been developed to solve problem in a fuzzy environment. Both criteria and weight could be fuzzy set. So we will assign weight for criteria and for alternative, and we will formulate that in the form of not normal set, but it will be in the form of fuzzy set. This analysis method has been widely used to deal with decision-making problem involving multi-criteria evaluation, selection of alternatives. So you can see the distribution of paper and manufacturing field. So these people, Winner et al., they use Vikor, basically type of study utilized, they use it manufacturing environment and the study purpose selecting a fit concept in modern manufacture. So Chatterjee, Faris, and all others, you can see the list is very long. So these people using Vikor and fuzzy Vikor in different robot selection and product designs. Okay, in robot selection you can see Taguchi method, product varieties. Similarly, distribution of paper and material selection. So these researchers use fuzzy Vikor in the material selection process. Okay, and the different researchers also use Vikor and fuzzy Vikor approaches in supply chain. For example, Zadeh used in the green supply chain, evaluated green supply chain by applied fuzzy Vikor. So the list is very long, and still people are using it, fuzzy Vikor in different multidisciplinary areas. So the step for fuzzy Vikor, so I will discuss in journal the mathematical formulation behind this fuzzy Vikor. And then in order that you people understand, in my next video I will discuss a very simple case study. So you need to remember these mathematical formulation. So what will be the step one? Step one, make a list of feasible alternatives. So just like this process is much more similar as HP and Topsis. What are your alternatives? Find the evaluation criteria. What are your criteria? On the basis of which criteria you want to compare your alternatives and you want to choose the best alternative and constitute a group of decision makers. So definitely you need to conduct a survey from whom? From the expert opinion. You need to get expert opinion. What the opinion of the experts? What experts say about a specific criteria and about a specific alternative. Suppose there are k decision maker. Let's suppose you want to get decision, you want to get survey from from 5 decision makers who are responsible for assessing M alternatives. So you have different alternatives. You want to buy a mobile phone, you're getting survey, you're getting help from 3, let's suppose, decision maker. You have 5 different mobile phones from different companies with respect to the importance of each of the N criteria, and you have different criteria. For example, criteria resale value, battery life, configurations, and camera, etc., etc. So in the step 2, so this step is much more similar as we have already discussed in AHP and TOPSIS. The step 2 will be identify appropriate linguistic variable and their positive triangular fuzzy number. So let's suppose in the fuzzy number, one decision maker will be say very good, the other will be say good, the third will be say not good. So now we need to construct, we need to transform these linguistic variable. We will transform this into the quantitative in the fuzzy number. Linguistic variable are used to calculate the importance weight of criteria and the rating of the alternative with respect to distinct criteria. For example, linguistic variable very high, so we will be known as VH, which can be defined by a triangular fuzzy number. So very high mean we assigning a weight of 0.75, A, B, and C. So this will be in the ascending order. Okay, ascending mean this will be the lowest one, then this one. So mean it can be same because 1 1, but it will not be like this that it will be 2 or it will be 1. So this is now for very high, this is triangular fuzzy number. Trapezoidal fuzzy number will be, let's suppose, 0.75. This will be let's suppose 0.9, this will be 0.95, and the fourth one will be 1. So that will be trapezoidal fuzzy number. Step 3, construct a fuzzy decision matrix. So just like we construct a pairwise comparison matrix, we will construct a fuzzy decision matrix for alternatives and alternatives comparison with criteria and for criteria, by pulling the decision maker opinion to get the aggregate fuzzy weight of the criteria and the aggregated fuzzy rating of alternatives. Let K is the number of decision makers. So let's suppose you get data from 4 decision makers in a group, and the aggregated fuzzy weight with respect to each criteria can be calculated. So this is mean, if I just write it, this will be the first. So mean you can see this is the plus sign, but this is different from that plus sign. This is basically the aggregated weight. So if we assign a weight, let's suppose the decision maker 1 will assign 0.5, 0.7 and 1. Okay, then plus 0.5, 0.9 and 1. So what we will do, we will add this first number of this, and then we will decide. So this will be 1, and then we will divide with the number of decision maker. So how many decision maker we have? Let's suppose we have 2 decision maker, then we will divide that with 2. Okay, so at this way we will conclude this step 3. And also aggregate fuzzy rating of alternatives. So we did that for the criteria, and then we will do this for the alternatives. In the supplier selection problem, the value of aggregated weight and rating are expressed in matrix format as follows. For example, supplier selection, we want to select a supplier. So first supplier, we have 5 different suppliers, and we want to compare every supplier with different criteria. So mean this one will be 1 against 1 criteria, supplier 1 against 1 criteria, supplier 1 against second criteria, and supplier 1 against n criteria. So we have n criteria. Supplier 2 against 1 criteria, supplier 2 against second criteria. So we will construct this matrix, and then what we will do, we will again calculate these weights. Okay, then in the 4th step we will do defuzzification. How we will do defuzzification? So you need to understand best north fuzzy performance. This is best north fuzzy performance formula, defuzzifying the fuzzy decision matrix. So now we need to defuzzify the fuzzy number. Defuzzification means we will bring into one number. Before, let's suppose in the triangular we have 3 numbers. So while defuzzifying it, we will bring into one number. If we have trapezoidal fuzzy number, so if trapezoidal fuzzy number mean we have 4 numbers. So we will bring it, we will squeeze it to one single number. So for defuzzification, we will be using this BNP, the short best non-fuzzy performance method, based on the COA defuzzification method. So this is the method. So for example, if we have 3 number, let's suppose 2, 3 and 5, let's suppose. So how we will use this? C. Which one is C? This one. So 5 minus 2 plus 3 minus 2 and divided by 3, and because why 3? Because this is a triangular fuzzy number, plus a, so a is 2. So at this way you will calculate the best non-fuzzy number. Then step 5, determine best crisp value and worst crisp values. So we will denote with f steric and f power minus, okay, for all criterion. Steric will represent best and this will represent worst by using the relation. So we will choose maximum from where? For the alternatives from this matrix. Which one will be the best benefit criteria, and for minimum for the cost criteria. Similarly, this one will be for the benefit criteria and this one will be for the cost criteria. Compute the value Si and Ri using the relation. Then we will calculate S values and R values. How we will calculate S values? This is the weight of criteria into this value, best crisp value, minus the value 1 into 1, which value? Minus the alternatives values, divided by best minus worst. And similarly R, the formulation is same, but we will choose the maximum only in the R. Then in the 7th step we will calculate Q value, which is very important value, and the formulation is this one. So V is basically the weight of strategy of maximum group utility. I will show you that how we will calculate, how we will check this value, but normally you not need to be confused. You can directly use this value is equal to 0.5. The value basically this value is representing, whereas 1 minus V is the weight of individual regret, 1 minus V. So this V will be equal to 0.5. If you reducing this, if it is less than 0.5, it's mean that you totally biasing to totally veto a specific decision. If this is equal to 0, so mean this is a consensus. And if it is greater than 0 point, then the majority say. So we will be totally rely on this V is equal to 0.5 and S steric minimum of S. So we have already calculated different S for different alternatives, and we have already calculated R for different alternatives. Then we will put all these values and we will calculate. Then in the step 8, rank the alternative by sorting each S, R and Q values in ascending order. Then we will give them in ascending order. Select the best alternative as compromise solution. So which one we will be choosing? Which will come on the first one in the ascending order, that will be our first priority. In the following two conditions, so we also need to check these two conditions. If the following two conditions are satisfied simultaneously, then the scheme with minimum value of Q in ranking is considered the optimal. So basically we will be choosing the minimum of Q value. So those alternatives whose value is minimum, those Q values for those alternatives which is minimum, then we will select based on that the minimum value of Q will be considered as the most optimal compromise solution. But you need to fulfill these conditions. The alternative QA1 has an acceptable advantage. In other words, so the QA2, so this is basically our first priority. A2 is our second priority. So what you need to do, the Q value of A2 minus the Q value of A1, alternative 1, which is on the top, you will subtract it from the second option, and you need to check that it is greater than or equal to 1 divided by m minus 1, m representing the alternative. So if this condition is fulfilled, then yes, you are ranking each and everything is alright. Your A2 is the alternative with the second position in the ranking list, and m is the number of alternative. The second condition is the alternative QA1 is stable within the decision making process. In other words, it is also best rank in S and Ri. So you also need to check the rank of QA1, the first alternative in S and R. If condition C1 is not satisfied, if this condition is satisfied, so the whole story is finished. If this is not satisfied, that means QAM minus QA1 is less than. So if this is not the case, then definitely the opposite of this one will be this one. Then alternative A1, A2, AM are all the same compromise solution. There is no comparative advantage of A1 from other. But for the case of maximum value, the corresponding alternative is the compromise closeness solution. If condition C2 is not satisfied, the stability in decision making is deficient, while A1 has a comparative advantage. Therefore, A1 and A2 has the same compromise solution. So if this one is not satisfied, then A1 and A2 are the best solution. You will not be able to decide that A1 will be the best solution. But if both conditions are satisfied, if this condition is satisfied, then you not need to come into this one and you need to decide on the basis of this one. In the next lecture, I will discuss a case study while using these mathematical formulation. Thank you.